In this video, I want to show you some examples of factoring expressions that can be found in the calculus. Look at this example. X to the 5 over 2 minus 4x to the 1 half. Immediately we notice that x is common between these two terms. But what power of x we have to factor here? Remember, when we factor an expression from some terms, we factor the variable with the smallest degree. For example, when we have x to the 3 plus x to the 2, we factor x to the 2 and then we have x plus 1. So we factor the smallest degree between the two terms. So here in this example also we have to follow same rule. So for factoring x, we factor x to the power of 1 half from these two terms. In this term we have x with power 5 over 2. In the other term we have x with power 1 half. And so we factor only x to the 1 half from these two terms. And remember, when we factor something from some terms, it's like dividing those terms by that common factor. So when we factor x to the 1 half from these two terms, basically to write this expression in the bracket, we have to suppose that we divide these terms by x to the 1 half. Now let's see, what is x to the 5 over 2 divided by x to the 1 half? We know that when we divide two terms with exponents, we have to subtract the powers. So this equals to x to the power of 5 over 2 minus 1 over 2. And this equals to x to the power of 4 over 2, because 5 over 2 minus 1 over 2 is 4 over 2, which is 2. So when we factor x to the 1 half from this first term here, then we have x to the 2 minus, what about the other term? When we divide 4x to the 1 half by x to the 1 half, when we divide this by x to the 1 half, x to the 1 half and x to the 1 half cancels, and then we have minus 4 here. Now look at the bracket. We have x to the 2 minus 4. This reminds us this famous important identity. A to the 2 minus b to the 2 is a minus b times a plus b. The difference of a square's identity. A to the 2 minus b to the 2 is a minus b times a plus b. By using this identity, we can factor this bracket. And we can write this in the form of x minus 2 times x plus 2. This is the factored form of this expression here. If you ask me where these type of expressions we see in the calculus, we see expressions like this, especially when we take derivative of functions. Expressions like this appear when we take derivative of functions in the calculus. Now look at this example. 2 plus x to the power of 1/3 plus x times 2 plus x to the power of negative 2/3. Immediately we notice that this is the common term between these two. 2 plus x. But what power of 2 plus x we have to factor? Again, the smallest degree. Between this power and this power, this is the smallest because this is negative power. So here we factor 2 plus x to the power of negative 2/3 from these two terms that here we have. This is our first term and this is our second term. And we know that when we factor something again, it's like dividing. So when we factor this, we have to divide this first term here by 2 plus x to the power of negative 2/3. And to write this expression here, we have to calculate this. We know that when we divide 2/3 like this, we have to subtract the powers. So the answer of this division here is 2 plus x to the power of 1/3 minus negative 2/3. This is 2 plus x to the power of 1/3 plus 2/3. Minus minus would be plus. And 1 over 3 plus 2 over 3 is 3 over 3. So this is 2 plus x to the power of 3 over 3, which is 1. So here we have 2 plus x. It's up to you to put a bracket for this or not. This is completely optional. What about the other part? When we factor this term here from this completely cancels and only we are left with x. So from the other term we have only x, so we have to write plus x here. And if you want, you can simplify the expression in the second bracket. So this equals to 2 plus x to the power of negative 2 third times 2 plus 2x. And this is the factored form of this expression. But attention, you can do something here. If you look at this bracket, 2 is common between these two terms. So it can be a good idea to factor 2 from these two terms and put that 2 in here at the front. So we factor 2 from these two terms, we put that 2 here, then we write 2 plus x to the power of negative 2 terms, and then we have 1 plus x here. When we factor 2 from these two terms, then we have 1 plus x. And if you wonder why I put 2 here, attention, between these two and this bracket and this is multiplication. In multiplication, the order of writing the terms is not important. Attention, when you have a times b times c, you can write it as a times c times b, or b times a times c. These are equal. So it's a good idea to put the 2 in front, because usually we prefer to put the simplest term as the first term and then we write other terms. So it's up to you. You can put the 2 in the middle here, but then your expression would be a little ugly. So this is better form for the answer. Now look at this example. X to the power of 3 over 2 minus 5x to the power of 1 half plus 4x to the negative 1 half. Try to pause the video here and try to do this example by yourself. Then continue watching the video. If you pay attention, here we have 3 terms and x is common between them. So we can factor a power of x, and we usually factor the smallest degree. So we can factor x to the power of negative 1 half. By factoring x to the negative 1 half, then we have to divide each of these terms with x to the negative 1 half. What is x to the 3 over 2 divided by x to the negative 1 half? What is the answer of this? If you pay attention, this is basically x to the power of 3 over 2 minus the power of the top minus the power of the bottom, minus 1 half. And basically this is like x to the power of 3 over 2 plus 1 over 2. 3 over 2 plus 1 over 2 is 4 over 2, which is 2. So we have x to the 2 here. What about this? Here we have negative 5 to the x times x to the power of 1 half minus negative 1 half. And this is basically negative 5 x to the power of 1 half plus 1 half. And this is negative 5 x to the power of 1. So we have minus 5x. And for the last term, it is obvious that x to the negative 1 half in numerator with x to the negative 1 half in denominator cancels, and only we have plus 4. So this cancels with this and we have plus 4. Finally, we can write this in the form of x to the negative 1 half times y, x minus 1 times x minus 4. If you pay attention here, we have a quadratic expression. And for factoring quadratic expressions or trinomials, we are looking for two numbers that their product is 4 and their sum is negative 5. Two numbers that their product is 4 and their sum is negative 5. Those numbers are negative 1 and negative 4. Negative 1 times negative 4 is 4. Negative 1 plus negative 4 is negative 5. This is the final answer of this expression here. We factor this expression to 3 factors, as you can see here. Look at this example. Here we have x to the 2 plus 1 to the power of 1 half plus 3 times x to the 2 plus 1 to the power of negative 1 half. It is clear that the term that we can factor is x to the 2 plus 1. But what power? The smallest power. And the power that is the smallest between 1 half and negative 1 half is negative 1 half. So we can factor this. When we factor this, Again, it means that we have to divide each of these by that factor. What is x to the 2 plus 1 to the power of 1/2 over x to the 2 plus 1 to the power of -1/2? Again, we have to subtract the powers. The power of the top minus the power of the bottom. 1/2 minus -1/2 would be 1/2 plus 1/2, which is 1. So we have x to the 2 plus 1 here. If you want, you can put a bracket for this, but it's not really necessary to put the bracket for this. What about the next term? If you pay attention, for the next term, this cancels with this. What remains? 3. So we have plus 3 here. If we simplify the expression inside the bracket, then we have x2 plus 1 to the -1/2 times x2 plus 4. Here we cannot factor this expression anymore because this is x to the 2 plus 4. If it was x to the 2 minus 4, yes, we can factor it. But x to the 2 plus 4, no, we can't factor it anymore, so we leave the answer in this form. Now look at this example. 3 times 2x minus 1 to the 2 times by 5 times x plus 3 to the power of 1/2 and so on. By looking at this term and this term, attention, here we have only 2 terms and the terms are really complicated. In each term we have several basically factors. We have to look at each bracket, each term, and we have to try to find common factors. For example, here we can see that we have 2x minus 1 with power 2, but in the bracket here we have 2x minus 1 with power 3, and so we have to factor 2x minus 1 with power 2. Always we factor the greatest common factor, which is the term with smallest exponent. So the first thing that here we notice is that we can factor 2x minus 1 to the power of 2 from this and this. Now let's take a look at x plus 3. Here we have x plus 3, here we have also x plus 3. In the first part we have x plus 3 to the power of 1/2, but in the other part, in the other term, we have x plus 3 to the power of -1/2. So what power we can factor? The smallest, and the negative is the smallest. So we can factor x plus 3 to the power of -1/2. What about numbers? We have a 5 here, but we don't have any 5 here, so we cannot do anything with that. What about 3? We have a 3 here. Also here we have a 3, if you pay attention. 3 in numerator. So if you want, you can factor a 3 and put the 3 here as a common factor. It's up to you. It's not really necessary to factor 3. You can leave the 3 for itself. But I'm going to factor 3 from these 2 terms. So by factoring 3 also, then let's see what remains from each term. Because we factored 3, so this 3 is gone. From this term, we have factored 2x minus 1 to the 2. So this is also gone from this term. From this term here, we have a 5, so we leave 5 here. What about this? We have factored x plus 3 to the -1/2, but here we have x plus 3 to the 1/2. So we have to divide this basically by x plus 3 to the power of -1/2. If we subtract this power from this power, we have 1/2 minus -1/2, and this would be 1. So this means that here we have x plus 3 to the power of 1. We don't need to write power 1 because anything to the power of 1 is the same expression. So basically we have only this. Now let's move to the other part. From this term, we have factored this, so this is gone. But from this term, we have factored only 2x minus 1 with power 2. But here we have power 3, so 1 power of this remains. So we have 2x minus 1 with power 1. And also we have factored a 3. So these 3 is factors. What remains from this fraction? A 1/2. So we have 1/2 here. Now the only thing that we have to do is to simplify this bracket here. So we have 3 times 2x minus 1 to the power of 2 times x plus 3 to the power of negative 1/2. If we multiply 5 in the bracket, then we have 5x plus 15. If we multiply 1/2 in the bracket, we have 1/2 times 2x, which is x. 1/2 times negative 1 is negative 1/2. Attention, this power 1 is not really necessary to write here. Again, if we multiply a little more inside of the bracket, we can write this in the form of times x plus 3 to the negative 1/2. 5x plus x is 6x. 15 minus 1/2 is 29 over 2. Because 15 is 30 divided by 2. 30 divided by 2 minus 1 over 2 is 29 over 2. And this is the fully factored form for this expression here. So you should be able to simplify, to factor expressions like this in the calculus. Then you are ready to take a calculus course. I hope this video was helpful for you to get ready for the calculus. If you like this video, please subscribe to my channel and see you in the next videos.